Okay, so this one is a lot more straightforward than the previous one, but I want to make sure, I give you some questions that up the rigor a little bit. We are preparing for calc and classes beyond, right? So I don't want to always go too easy on you. But in this particular question, right, we're talking about in 1986, nuclear reactor accident happened in Chernobyl. You may have heard of it. I'm sure there's like half a dozen horror stories, movies made out off of this. A couple come to mind. The explosion spread highly toxic radioactive chemicals like plutonium over hundreds of square miles, and the government had to evacuate the city and the surrounding area. It's a little creepy if you look at pictures of it, which again, that's why they have horror movies about it. The city is now uninhibited, and they use a model to help kind of determine when these chemicals are no longer present, right? They have this thing called half-life. You should have learned about that in a Math 102 class, where we measure how long it takes for there to be half of the original quantity of substance that was there. So in this case, half of the original amount of plutonium. So this model that they're using, this formula that they're using, we see it right here in the middle, right? P is equal to 10 times 1/2 to the power T over 24,100, right? It's a pretty massive exponent, but that's okay. It represents the amount of plutonium, P, so notice that's your value right here, yeah, that is still there from an initial 10-pound quantity after T years. So consider this function over the interval, and I am noticing my years are not there, where T is equal to 0, that initial amount, we saw a similar kind of notation in the last question, represents 1986. That's when the incident occurred, right? How much of that 10 pounds remains in the year 2020? And are we able to figure out how much remains after 100,000 years? Okay, so the amount of plutonium there, the amount that remains, is directly tied to this value P, right? This is exactly that, the amount of plutonium P that remains from our original amount, right? From our original 10 pounds. So if we can calculate in this year, in this 1986 year, this formula, if we can find the appropriate values to plug in, we can determine how much of that plutonium, how much P remains. So to get to this, we are looking in the year 2020, right? So essentially, we need to figure out what's the difference between now and 1986. And if you do that subtraction, you end up with 34. 34 years. And that tells us T is equal to 34. So the first thing that we're going to do, I'm going to tie this with my 2020 right here. We want to find P when T is equal to 34. So 10, 1/2, 34 over 24,100. Again, just like the last one, you could write that as P of T. Sometimes that helps just in distinguishing what piece you're working on. It's just the function notation. So if we throw that exponent on a calculator, that's this part, right? We end up with 800. We end up with 0.0014107884, and I need 1/2 raised to that power. And this might be an excellent example of where 0.5 is more helpful than 1/2 on a calculator, right? So if we raise that exponent to that power, 0.999022594 times 10 essentially moves our decimal over one place. So P is equal to 9.990229594. Now the unit on that is pounds, right? So this is in pounds, which is really unfortunate because after 34 years, there's still 9.99 pounds remaining, right? So let me write that out. After 34 years, there's still 9.99 pounds remaining. I almost feel like that deserves an exclamation mark after it, right? That's pretty serious amount after 34 years, right? Okay, so the second part asks us to find this after 100,000 years. So let's find that part. So you've got P is equal to 10 times 1/2 100,000 divided by 24,100. Now you notice this time around, that's too many zeros, the numerator is a larger number than the denominator. That actually will help us. It'll help the people of Chernobyl. It'll reduce the quantity. So if you throw that on a calculator, this portion, just the exponent calculation, is 4.149377593. If you do 1/2 or 0.5 to that as an exponent, you get, that's this portion, you get 0.05635244602. And again, anything times 10, all that does is move the decimal over one spot. So the amount of plutonium left after 100,000 years is still 0.563524602, which is still kind of mind-blowing, right? That means after 100,000 years, they're still not completely gone, right? There's still 0.5, let's round it, maybe 0.57 pounds of plutonium. So just think about that for the city, right? It is uninhabitable for over 100,000 years, depending on how comfortable you are with plutonium, right? Probably not that comfortable, but it's pretty devastating. And that's not the only, city that has experienced something like that. I know Japan has experienced that. So it's a pretty serious thing. You can see it takes a long time for it to get cleaned up and just to kind of die away on its own. All right.